being here for the talk. Like Julie said, my name is Ezekiel Kaufman. A little bit background about me to, oh, that would be helpful. Good? All right, we're good now. All right, sorry. Yeah, so just a little bit about me and to sort of contextualize the approach to the talk. I'm from Anchorage, Alaska. I moved to St. Louis a couple of years ago because of him to work for our company. My whole background academically is in the humanities. I studied history, political philosophy, sociology in undergraduate school. I engaged in social science methodologies and research in school, and then in graduate school, I studied sociology and criminology. And I got my master's in criminology. Professionally, all I've worked for was government agencies. I worked with the state of Alaska's big Medicaid agency that oversaw a budget of $500 million. I was the lead research analyst for that agency. I also worked for the state's prosecution agency, which managed and oversaw 13 separate equivalent to district attorney offices. Then I did a brief stint as a child protection investigator, where I was investigating allegations of child maltreatment. So all that is to say, no background in technology. The company that I work for now is really the first time that I've jumped from a tech side, or to a tech side, from a social science policy side. So in the presentation, I'm going to have certain quotes and certain mentionings of different sociological principles. But when I made the jump from social science to technology, I noticed that there was a lot of the same activities in terms of people's interactions with data. There was a lot of the same thought processes around sampling, around trying to figure out typicality with data, how to clean it, how to analyze it, that I saw in social science. But there was certainly a difference in vocabulary, and there was a difference in a methodological approach and an ultimate understanding of what the data is. So I thought it would be really interesting to bring a talk, bring a social science perspective to a data conversation and using different SQL techniques to flesh out some of the data. So. Now, I want to sort of extra contextualize the talk. So in the world of social science, you're always engaging in two things: the ontology, or the nature of the thing under study, and then epistemology, which is the methodological considerations and tools that you use to examine, to understand the nature of the thing that you are studying. So, and we always term that as the empirical realities or the social processes that are under examination. I'm going to flesh out those concepts a little bit more in the talk to make it a little less esoteric and a little bit more practical. But I wanted to start with a couple quotes and a couple sort of foundational principles. And anything that we study, that we analyze, whether it's a database that the DBA is working with, a software application that the development team is building, is analyzing, or the final empirical world that the data is originating from, whether it's healthcare, law enforcement, education, private sector logistics. All of these things, you can think of it, and I think it's important to think of it as an empirical reality that is external to you, but is coercive thereof. Meaning you interact with it, but part of that interaction is both forward, coming from you to the data and the systems that those data produce and those data live in. We are also reacting to it. Those systems talk back to you.
Sorry.
Yeah.
We are seeing the center version of this online.
Yeah. Let's see if that works.
Are you sharing your entire screen, or are you sharing
The screen?
Red border was running over.
I'm sharing the screen. How's that?
That was a red border.
Okay. I swear I can work technology people, despite everything I just said. Yeah. So there is a really great quote from one of my heroes in sociology, Herbert Blumer. And it says, the empirical world can talk back to our pictures of it or assertions about it, challenging and resisting or not bending to our images or conceptions of it. Practical terms, think about any application you ever work with. Now you're developing it, you're maintaining the current version, your clients are testing it, providing you feedback, you're getting death by exceptions as you're trying to build something new, a new feature. You deploy it, your clients get back to you. I mean, it's a constant feedback loop. So what you thought was an amazing piece of the software might be the most exceptions producing aspect of the software. So again, it's a thing, a nature of a product, an empirical reality, a social process that's talking back. So again, we have the nature of the thing. Then the other piece is the methodology of it. So methodology refers to or uncovers the principles that underlie and guide the full process of studying the obdurate character of a given empirical world. And I love that because of the word obdurate. So anything that we're doing, at least in our world, in case management systems and prosecution offices and defense agencies, those worlds which we're having to produce data for, to clean for, can be the most confusing, stubborn, wildly looking data that you could possibly have. So trying to make sense of that, to flesh things out, can be a real challenge. The other piece, too, that is particularly unique about analysis is that has such a tremendous role in what I say all the time and what was coined in sociology as the definition of the situation. However something is defined, where, again, the application that you're using, how your company defines it, how all of your different clients define that software, how the community partners define the products that come from that software, all of those things can be competing definitions of the situation, competing evaluations of that product. Analysis is a path that can inform an organization's definition of the product, of the situation. The other piece, too, is with exploratory data analysis. So I have a quote here saying, the more that one knows about the data, the more effectively data can be used to develop, test, and refine theory. Now, one thing that we experience quite a bit, and I'm curious, based on people's facial reactions, if you experience this too, every single person I ever interact with has an opinion on data, has an opinion about some policy outcome, some political position, something. But it's very hard to flesh out what data sources, what analyses that the opinion is based on, which from an analysis perspective, a social science perspective, if you can't demonstrate the sources, you can't demonstrate the methodologies and have them be testable methodologies, accountable methodologies, the opinion or the definition of the situation is on really shaky grounds. So the other piece too that I have an image here is there's another concept of how we can think about data. And it's something that, I say all the time, data does not exist in and of itself. It has zero value in and of itself. A number is a number. A spreadsheet's a spreadsheet. What it does is that it reflects back the process. It's reflecting back whatever you are analyzing and all of the social processes, the organizational policies, the development methodologies that are being utilized to produce that data. So I hear all the term, oh, this is dirty data. Oh, it's dirty data. And I'm like, no, the data is the data. It's not dirty or clean. Your process is dirty, and the data is simply reflecting back to you all of the missingness and the confusing aspects of your data and the weird data types that somehow are meshed together, the XML that's 8,000 lines long, the procedure that is like death by dynamic sequence. That's the part that's dirty. Data is just reflecting that back to you. I have it here too. This is really for Julia Morali with the DBA and the different people who can look to find the person. In our world, my colleague and I are the accidental DBAs for our office, and the people we battle with the most are our developing teams. These guys are code, we're data. So there's two things that I want to do throughout the rest of the presentation. Big thing is I want to talk about the process of doing the work of exploratory data analysis and all the components that go into that. The other piece is, as we're talking about these concepts and these principles, I just want to showcase some techniques that you can use in SQL to engage with these different methodological concepts and perform analysis from different angles. Now, these aren't the only techniques to use, and these aren't the only ways to write these techniques. But one thing that I see all the time, again, coming from social science, is that in the technology world, it's a very normal thought for people to think they can just data visualize their way out of true analysis. Like, we don't need to analyze the data. Power BI will solve everything. And it's like, yeah, it's a powerful tool, but like, what's the thought process behind the data model? What's the thought process around the 15 data sources that you're pooling together? Why are you using that method for your mQuery or your Power Query as opposed to another? You can't just let me Power BI my way out of this thing or Tableau my way out of this. But we see that actually quite a bit. So I want to disabuse us of that notion and actually look at certain techniques that we can flesh out data. So I'm not sure how much, I mean, I've heard introductions, but I'm not sure how much people know about criminal justice data and data sets. So what I want to do throughout this presentation, if anybody has any questions, please interrupt. I'm not looking at the chat, by the way, but I know Julie and Morali are. Yeah, if I'm going to talk about a data set or the nature of the criminal justice world this data set is coming from, or any of the different concepts, please interrupt. I'm more than happy to take a couple seconds, flesh things out, and then get back to it. I want to showcase a particular data set called the Law Enforcement Employees Data Set. For those of you who don't know, there is a federal program that's been in existence since the 1920s. It's been called various things, but for the last few decades, the Federal Bureau of Investigation has owned this project, and it's called the Uniform Crime Report, or the National Incident-Based Reporting System. It's a massive federal program that all these law enforcement agencies throughout the country can volunteer to participate in. What they do is they just send data over to the feds. They send arrest data, employee data, officer-involved shooting data, officer suicide data. It's a massive ecosystem of data that they send to the feds. Beauty is it's all publicly available. which is just absolutely amazing. So in fact, let me just take a break for a second and show it to you. So this is the website from the FBI. It's functioning today. So you go, this is, yeah, thank you. Yeah, in here, you can look at, you can look at all the different data sets that are available on the left side of the screen. And they all come in Excel or CSV files. Yes? It's cde.ucr, but if you Google UCR, that's the first thing that's going to pop up. Yeah. Oh, yeah, sure. Yeah. There you go.
So is that familiar or to your play with Chicago crime data? Is that similar where it has the geographic line top of crime category? That's a nice little hierarchical
Yeah,
dimension.
great question. So most likely. So the other piece to this, whenever you hear in any news agency, broadcast news, newspapers, and a substantial portion of advocacy organizations, law enforcement agencies, when they report out to the public about crime stats and law enforcement stats, more than likely, they're pulling their information from this. This is the largest survey of criminal justice data that exists. It probably does. I have not gone through the various data sets since grad school 10 years ago, but it's likely. Okay. Oh, is it back on the presenter? Yeah. It is. Oh. How did I get rid of that? Screen. There we go. Once I get to SSMS, then that will end. So I pulled the data set for the law enforcement employees. I'm just going to call it the LEED. It consists of about 800,000 or 750,000 rows of data, 64 years worth of data, covering a little under 22,000 police agencies across 50 states and 5 territories. And the divisions and regions are just the geographic aggregations of the US and then its territories. So a large volume of data in this one data set. First thing I want to talk about, and we're going to jump into SSMS in a couple minutes, is methodologies. Different than statistics, which a lot of times people treat that as synonymous to quite different things. There are 5 key parts. I got to keep looking at the computer to show everyone online. There are 5 key parts that you need to keep in mind for research methodology. Levels of analysis or levels of granularity. In the business intelligence world that I've seen from a tech side, I've always heard them talk about this in terms of hierarchies, especially in Power BI, how you can set a hierarchy and have your different visualizations aggregate at those different levels. So in social science world, that's levels of analysis. Critical thing to keep in mind is something called an atomistic or ecological fallacy. Basic gist, if you're at one level, you stay at that level. You don't analyze at one level and then reach conclusions at a different one. So if you're talking about city level crime, you better not start making statewide conclusions. That's not the level you're at. But I see that all the time. People will be analyzing data at the individual level and they'll say, look at the entire organization. Like, that's not the organization. You're talking individual level.
So the difference between developers and politicians.
Yeah. Yeah. The other piece is a unit of analysis, a little bit different than level of analysis. In the BI world, I've heard people talk about it as data granularity, and again with hierarchy. If you look at the law enforcement data that I'm going to start playing around with, levels of analysis for that data set is the individual law enforcement agency. But the data set covers years of data per law enforcement agency. So in that data set, each unit, or each row, is a year's worth of data for an agency. So when we analyze this later in the presentation, we're going to be making conclusions about law enforcement agencies, but our unit is yearly counts per agency. It's very hard concept to keep in mind, by the way. This many, many years of schooling to flesh that out in different contexts. The other piece is sampling. And I always hear people say, oh yeah, let's get all the data. We got tons of data. Where did it come from? How was it collected? And even when you're analyzing it, how are you breaking it apart? How are you teasing it out? There's different ways to do that. And it's called sampling methodologies. You could have a simple random, stratified, or purposive, or theoretical. Sometimes you're just wanting to look at a very specific problem with the data. That really, you're going to do a theoretical sampling methodology to grab that subset and analyze it. And again, you're staying in that group that you're pulling out and teasing out. You're not going to draw out to a larger inference. Then we jump into statistics. We have descriptive statistics and outliers. I have in here in the BI world, and I'm using Power BI as my reference point here. I'm not sure about Tableau. I presume it's the same. But when you're pulling in data into Power BI, you can compute these different column profile and distributions. And you can do some anomaly detection. That's outliers and doing descriptive stats. Lastly is hypothesis testing. And this is the piece that I love doing and I think is really interesting. In the Power BI world, I've seen two data visualizations that perform statistical work, although to me, it's like a black box of how it works. That was the key influencers visualization and then the decomposition trees. But again, as a social science person who builds stats models from scratch, having a visual that I don't know what formula is used, it's a black box to me. Okay. So going into sampling methodologies. So in a second, I'm going to go over to SSMS and we're going to start playing around. But the T-SQL techniques that we can use to tease out data and examine subsets of that larger population are these three functions, system functions: table sample, new ID, and RAND. Now the syntax for new ID and RAND are exactly what you see up on the screen. Table sample syntax is going to be performed in the join operations. So, and you'll see that in a second. I put up the continuum here of the different sampling methodologies. And I put it on a continuum because anytime you're thinking of the data and analyzing it, you may make decisions that are more methodologically driven or that are more theoretically driven. So in this presentation, I'm going to spend a lot more on the theoretically driven piece, really for the sake of making the presentation a little easier. So let me go into SSMS real quick. Okay. I need my glasses. So looking at the data set here, the table sample command is really easy. So you just select columns you want. Yes. Better? All right. So you're selecting the columns from the table, but within the table function, you put in the table sample syntax. You can either sample it at the percent, or you can sample actual rows. And then you just finish it off. Now there are, yes?
What is the same function algorithm?
Great question that I do not know the answer to. But what I can say, and I'll say it in a second, is the sample piece is based on the data pages within the data, stored within the database. So when I say 10% here, it's 10% based on a data page. So even though I'm saying, give me 10% of the law enforcement agencies that exist within this data set, which theoretically should be 70,000, roughly, rows of data that get returned. It's based on data pages. So whatever is 10% based on the data pages is what's going to pull up.
Not 10%.
Correct.
Is it 10%?
Yeah, that's a great question that I also don't know because the Microsoft documentation doesn't really flesh that out.
Yeah, I would be surprised if they did tell you what was going on under the hood, but like you said, somebody may come back and question, well, how was your sample?
Yep.
You can't explain.
Yeah, absolutely. Oh yeah. Oh, absolutely. And this is in a second. And this is also important. Oh yeah, sorry, thank you. Yeah, the question was the behind the scenes what is the behind the scenes algorithm for table sample? Yeah, yeah, and again, that I don't know. Couldn't find Microsoft documentation, but it's an important point because using this system function, you might end up having a disconnect or a little bit of drift from the actual analysis you're wanting to conduct and the lens through which you want to analyze law enforcement agencies and what the system function is actually performing for you. So that's an important methodological limitation of using this particular technique. Well, let me run it so we can see what the results are. And oh, I forgot to turn on my zoom in. But bear with me for 1 second. There we go. Okay. Yeah. So in this just brief example, just pulling the year and the law enforcement agency. So, and I pulled 75,000 law enforcement agencies. Now, if I wanted to go a little further, I could start including page information in here to really track it down in terms of the data storage locations, but didn't want to make it too complicated. Very, very important piece of using table sample is that you can only put it as a join, as a condition on a join, on a table. Can't use it on a view, can't use it on a table function. I didn't try it on a temp table, but yeah, it has to be on an actual table. So, which is real limiting because if, I mean, I create CTEs all the time because I just want to create a little sample of something and then I'm going to start building queries off that. So this is not the optimal methodology for doing that.
Self-reported data, by the way.
What do you, self-reported data?
Well, like, I mean, you said that all these.
Oh, yes. Yep.
That's what they
Correct.
That probably is the basis for most dangerous cities in the country, highest murder rate.
More of resources, and yeah, resources is the biggest limitation. I mean, you can say politics, but 22,000 agencies have been report to the feds this data, and this program's been around since the 1920s. It's nationally accepted. So the big barrier for law enforcement agencies to report is whether or not they have staff to take their records in various forms, hard file to electronic, compile it, and send it to the feds. Good conclusion. Yeah, question.
So you're taking samples completely random, like plastic every time you get a different sample, or will it be if I am doing a sample from the same table, like it's the exact same sample every time?
Great question, which was, is table sample actually producing a random sample that I'm wanting? And it can, but it's not the best one to use. I would prefer to use the next two that I'm going to show. Yep. All right. The next two, just commented it out, is the new ID and the RAND. So new ID produces that GUID, that alphanumeric unique identifier. And that's the whole purpose of doing select new ID, just get that. RAND produces a randomized number anywhere between 0 and 1. Separately, they have some randomization, but to make it really random, you could merge the two together, which is what I'm doing here. So the syntax for this, and I'm going to zoom out, but I'm going to look at Julia Morale to tell me if I'm zooming out too much. Okay. So the technique here is going to be using a lot of dynamic SQL because here I'm engaging in stratified random sampling. I may want to swap out different agencies to get the data. So I set the sample size that I want. I set the percentage of data in the larger data set that I want to pull. And I use the randomizer methodology of whether I'm going to do new ID or RAND or both. And then I'm identifying the agencies that I want to look at. And then set those values here. Now here's an important piece. Just a second ago I said I'm going to use stratified random sampling. So that means I want to pull a sample within each of the groups in my strata. So a random sample of each law enforcement agency that I'm going to pull here. And for the sake of this example, I'm going to look at St. Louis Police Department and Anchorage Police Department. Anchorage Police Department in Alaska. So first things first in this dynamic SQL is I want to create my select top statement so that I know whether I'm going to select top 15, top 10%, top 80%, top 100, etc. Second step is to build sort of the rest of my select statement. I'll have a section in here to tell me in my where condition of what randomizing methodology I'm going to use. And don't worry, I'm going to, as part of the execution here, I'm going to show you what the final script looked like. So we're not just looking at dynamic SQL. And because I'm doing randomized samples within each agency, for this, I just put it in a cursor. Again, oh, I'm not looking at APD. I'm looking at Kansas City and then St. Louis City. So for this example, I pulled 10%, 64 years worth of data, 10% of that, roughly 7 years each for Kansas City Police Department and St. Louis Police Department. And then it pulled these years. And if I were to run this over and over again, it's going to pull different years, which you can see there. Here's what the final script actually looks like. Once you're done dynamicizing everything, this is what it looks like. I'm getting top 10% from my tables for this specific police agency, but order it by this randomizing sequence here in my order condition. So in terms of which way would be the most optimal way of getting a random subset of your data, like let's say you're QAing something, and you need to grab a bunch of data just to QA it. This methodology, I would say, would be the most optimal way to get there. All right. Please don't go back to presenter mode. There we go. Okay. Descriptive statistics. Yeah. Convert? Oh, in SQL, when you're working with different data types, you can't perform certain operations based on the data type. Like if you have a number, 1, 2, 3, 4, but it's stored as a varchar, you need to convert that into an integer, small int, tiny int, etc., in order to perform some mathematical operations. So in there, I converted new ID, which is an alphanumeric GUID, into a var binary, which is necessary in order to have that be a seed value. Yeah. All right. So I am hoping at the end of this, all of you will never ever again say the average of something. That's the bane of my existence. I hope everybody here is going to say the typical. No more averages. That's a ubiquitous term for typicality, which I've spent so many hours editing papers for that. Whenever you're performing statistics, you really need to keep in mind the levels of measurement, or in the SQL world, and most likely the programming world as well, you're talking about data types. Certain data types call for certain statistical methodologies and statistical techniques. And phrasing it differently, you can only perform certain techniques based on data types. So I have the breakdown here of what the different data types are, both in terms of social science language and in SQL language. And then that last column there, I have it translated into the data set of what those are. So nominal or category is just categories that have no inherent ordering, and you can't order it whatsoever. Gender, race, law enforcement agency, these are categories. You can't order them. And it would make sense to order them. There's no inherent mathematical value. Ordinal is like categorical, but there is an order to it. So if anybody's ever filled out a survey and you have the strongly disagree, disagree, agree, strongly agree, that's an ordinal measure. So, because there is an order, but it's not a true mathematical order. Then the last two are interval and ratio, or in the SQL world, it's the bits, the tiny ints, the numerics, the decimals, stuff that you can perform true mathematical operations on. The other piece to keep in mind, which really affects analyses, which is again why I say you can't just Power BI your way out of something, or data visualize your way out of something, is you have to think about the distribution of your data. And there's two things you need to worry about, the skewness and the kurtosis. So in other words, how centralized and grouped together is your data, which speaks to kurtosis. Now, if you have 90% of your data here, you have a real centralized distribution of data. Or you could have, it's called pleitoturtic, where it's really spread out, in which you basically have a data set of nothing but unique values. The other piece is the skewness, where you have positive and negative skew. So just for the sake of simplicity, if anybody's ever heard of income and being reported, they always say the median income, and that's because the average income or the mean income is so incredibly skewed. And it's a crazy positive skew because you have the bazillionaires who make bazillions of dollars who are pushing the tail of the distribution to the right, while the vast majority of people aren't bazillionaires. So the way to handle that is to do median, which isn't so affected by skew. Here are the different descriptive statistics that are incredibly informative for any exploratory data analysis. And again, please, 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 never treat average as the catch-all for typicality. Any question is, what is the typical situation, the typical distribution? That's what we're looking for. Next question is, well, okay, you tell me how typical something is. How typical is the typical? And that speaks to dispersion or variability. I've seen a lot of different SSRS reports, a lot of Power BI reports, and I've seen, especially in Power BI, when you have a graph, you can add a little visual, I forgot what it's called, I'm blanking on that right now, but you can like right click and say put in an average line or put in a median line just to show you a baseline. Great. However, in that distribution, would an average line or mean line in the social science world, is that even informative, or is it skewed? Is that mean way higher than it needs to be? Like, great, you gave me another visual, but how informative is that? I don't know what the typical is. So, let's start looking at typicality. Okay. So for this example, I'm going to showcase Kansas City, St. Louis, and Anchorage, and showing you what that looks like. So this producing typicality gets pretty involved for SQL techniques. Because again, if you look back at that PowerPoint, which we'll go back to in a second, you have minimum value, maximum value, range, the modal category, which is the most frequent, a measure of dispersion for that. You have the median, the measures of dispersion for that. You have the mean, or as everybody calls the average. You have a dispersion measure for that. So it's like a ton of different statistics just to show you what the typical situation is and how typical it is. So, does anybody have a preference? Kansas City, St. Louis, or Anchorage? All right, no preference. What was it?
Dealer's choice.
Dealer's choice. There you go. Well, I already have it up here for Kansas City, so we'll do that. Now we're going to do this. We're in St. Louis. Come for the agency. Yep. Oh yeah. So that was good. That was what I needed to be. Okay. So one thing that you notice in this script is I variabilized a lot of things. In the beginning of the script, I have the agency, number of observations, which is number of cases, and then this data set's the number of years, a mean officer total, variance and standard deviation. Notice that I put it as floats. And that's because when you're computing variances or standard deviations, decimals are going to start coming in really quickly, and they'll become very relevant. And for simplicity purposes, in here, I'm looking at officer counts. So how many officers exist per year per agency, just to keep it a little simple. So first things first, let's get a count of the observations that exist. So meaning the number of years of data that exist per the agency. Because again, our unit of analysis is a yearly count per agency. Then we're grabbing a mean officer total. And I'm going to start using that word. I'm so used to saying mean. Average is weird to me. So I'm going to say mean, but just know that it's average.
This is recorded, just so you know, once you go out, you get pulled over, you know, that doesn't mean officer.
Yeah, exactly. They appreciate intellectual conversations about personnel throughout the years of their agency. So if you do get pulled over, you're like, I just heard this talk. You guys need more people. And then you'll be golden. Yeah. So to get the mean across the years. Now, again, SQL does have an average function. It's disappointing they don't call it mean, but they do have an average system function. I'm purposely not using that function here because I wanted to just showcase, compute the mean. You have a sum of all the observations divided by the sample size for that agency. So I purposely wrote that out instead of just relying on the system function.
Are you doing the one time system?
Great question. So the question was, why am I using 1 times something before I do that? SQL does not like computing division or performing division on pure numbers when the output of that division is going to be a decimal. So to avoid that, you just make everything decimal. And it's another way to do it. So doing 1 times this is a way to avoid having this. We go convert decimal, I don't know, let's do 16.5. I mean, to me, that's ugly. Yeah. It could be that I'm sensitive because in my colleague and I, we tune and optimize 20 years or functions and procedures that were built over 20 years by 16 different development teams. So when we see extra verbiage, we get pretty sensitive.
Automatically casts it to a decimal float or
I think it converts to so he asked if doing the 1.00 times the number, what data type it converts it into implicitly. I think it's float, if I'm not mistaken. Yeah. All right. So I'm looking at the clock to make sure that I'm still on track here. Nope. Cancel that out. There we go. Deviations from the mean. Why are you working for me now? Deviations from the mean. Put it down here. Oh, I opened up the wrong thing. I meant to open up this. Sorry about that. All right. So in here, this is what I was looking at. So we're going to look at Kansas City, St. Louis, and Anchorage. So that's what's throwing me off in that other one. I was like, I wasn't supposed to be doing that. Let me just get rid of that so I don't open it up again. Okay. So if for those of you who don't know, a nice data visual that's super common is called a histogram or a column stack bar chart or bar chart. It's that. So I saw a technique that uses SQL to produce a histogram within SQL. It's not particularly useful, but I thought it was kind of cool. So I put it in here. So let me get rid of that and show it to you. So if you're going to produce that histogram, you need to have, or I did, a CTE in which I'm taking the officer counts. I'm categorizing that because I can promise you this distribution is so varied that basically every single value was unique. So the histogram was just basically ones across the board. but I grouped the officer counts into these categories that you see on the screen, and then it just did a simple count of observations. But instead of having a number to say that there are 7 years that have an officer count of 1,000, I replaced the 7 with these asterisks using replicate. Doing that gets you this really nice histogram. So this will tell you for which agency am I looking at? St. Louis. I'm looking at St. Louis. So this tells you that across the 64 years worth of data, St. Louis, most of the time, like nearly always, has some sworn officer count anywhere between 1,000 and 2,000. And we're going to see more of this a little bit later. Get to the behemoth of descriptive stats. So I'm going to run it, show you the output, and then I'm going to break it down. So for the Anchorage Police Department, Kansas City, and St. Louis City Police Departments, or the St. Louis Municipality Police Department is I think what they call it. We have 63 or 64 years worth of data ranging from 1960 to 2023. We have minimum officer counts, maximum officer counts. So on the bottom here, that's telling us that 2,229. One of those years, St. Louis had 2,229 sworn officers on staff. And this is St. Louis City, not St. Louis County. Sorry. We have a modal officer count, which is the most frequently seen count of officers. Variation ratio, which is a measure of dispersion for mode. And I'll interpret that in a second. We have medians, measures of dispersion for medians. And then lastly, we have a mean score and a standard deviation, which is a standard measure of dispersion for means. So I'm going to circle back to that, but let me show you the breakdown. This one's very involved. And it's going to be a lot of stacking of CTEs to get to the final output. So first things first is I'm building a CTE so that I can compute the mode, the median, and their dispersion measures. So I'm looking at my data set per the agency, grabbing the agencies as my main where condition so I can target that down. I'm doing a preliminary step here to get my officer count frequencies. So it's using row number. I'm doing a partition over the unique identifier for the agency, which is the ORI, the agency itself, and the officer count. So that as this preliminary step, it's going to say here an officer count of 1,000. There was 2 rows for that. An officer count of 1,539, 3 rows for that. So using this row number or this window function as a method of doing that preliminary step. I'm going to pull that back in down below. To compute the median, again, I'm going to use a window function, and I use the percentile continuous, and I'm identifying the 25th percentile, which is the lower bound, 50th percentile, which is the actual median, then the 75th percentile, which is the upper bound. Partitioning that by the agency, and I'm going to order by the officer count. So just a real quick step for those who don't know, a median score splits a distribution in half. So it's known as the 50th percentile. So if you were to order all of your data from lowest value to highest value, find the middle, cut that in half, that's your median. So doing this big data set just to get the preliminary steps of the mode and median scores. And then I'm going to bring that back into this second CTE, in which I'm going to do some additional, I'm going to call it self-join, but I'm outer replying back to that first CTE so that I can do additional computations. So, and you have to use distinct here because I'm using window functions, which is going to be a lot of repetitive outputs. So I just want one row per agency. So I'm distincting my way out of the duplication. It's like the one time I actually would support using distinct, by the way. Yep, mode and median. And in this outer reply here, that's where I'm going to pull back that officer count and the officer frequency in order to produce my modal score, or again, my most frequently seen officer count. In here, I'm grabbing my median, and then I'm computing the main dispersion measure, which is called the interquartile range. And an interquartile range, basically just for that, it's going to produce your boundaries to show you what 50% of your distribution is grouped between. So when I pull up the results back, I'm going to interpret that. And then the final bottom piece is when I'm going to start using more SQL system functions to get the minimum scores, the maximum scores. And then here, I'm using average to get my mean, and then standard deviation to get that dispersion for the mean score. There's another dispersion measure for mean, for those who don't know, it's called variance. That becomes relevant with statistics. But straight descriptive stats, standard deviation is the standard. And because I'm having all these aggregated functions in here, I'm going to have a group by. So again, let's run that. There we go. So I'm going to zoom here. So one thing that you notice, I'm going to start with the mean and the standard deviation. So the mean officer count for, what's the top one? Yeah, Anchorage, Kansas City, and St. Louis. Okay. So the mean number of officers for the Anchorage Police Department over the last 63 years is 262 sworn officers. But you can see, based on the standard deviation value of 118, 262, highly variable. I mean, it's not a solid, like 262, take it to the bank, that's golden. That's a highly variable value. And if you look at Kansas City and St. Louis, you have a mean officer count for Kansas City of 1,178 with 146 officers as your variable for your standard deviation. That's actually not too variable. When you have a mean in the thousands, or low thousands, but a standard deviation in the low hundreds, that's not that variable. That means your distribution is resembling pretty closely to a normal distribution, as opposed to being negatively skewed or positively skewed. And if you look at the median and the interquartile range here, you can see for Anchorage, 50% of the years, half this, about 32 years, 31 years, the officer count was somewhere between 280 officers or lower. Half of the years ranged somewhere between 69 officers and 507 officers. So again, it's quite variable, but given the skew that we can see by using the mean score, if you want to say what's the typical number of officers the Anchorage Police Department has had over the last 63 years, I would say you want to use the median, which becomes very, very relevant if you're going to start bringing this data set into an advanced visualization program like Power BI. Now, in Power BI, we always have to worry about the size of the model. And there, you read everywhere, yeah, you want to, if you're going to be reporting aggregated information, you're going to take a big hit if you're going to pull in individual level data to then just aggregate it either in Power Query or in your DAX. So if you're going to say, okay, never mind, let me just pull aggregated information. If you were to pull the whole data set and just do your mean computation in Power BI, you're going to be pulling a big data set. So all right, let's get back to here. Hide presenter view. You have to constantly hide presenter view. Any analysis. So I'm going to speed up the next couple of slides for the sake of time. But let me say the gist piece here. Every single analysis is driven by a research question. You want to know if there's a difference in something. You want to know if the distribution that you see is what you would expect to see. These types of questions. Stats world is called hypothesis testing. You have a question, you have a thought of what you think you will see, and then you're going to perform a statistical technique to analyze that assumption. There are things to worry about and things to calculate, but I'm going to skip ahead of that. But during Q&A, if people have questions, I can answer what type 1 errors, type 2 errors are. A first statistical test, which is like a beautiful test to run, especially for nominal and ordinal data, so categorical data, is a chi-square test. There's many different types of chi-square tests, but this is these two are pretty standard, 1 sample and 2 sample. The basic formula here is this symbol is the symbol for chi-square. So we're not squaring a value of x, that's just the symbol of it. So a chi-square is effectively taking the observed values in your distribution, comparing that to what you would expect to see under what's called the null hypothesis, squaring that value, dividing it by the expected, summing all that up. And I'm going to show a practical example. So a 2 sample chi-square is same thing. You have a table of data, you have your observed values, you compare that to what you would expect to see under a hypothetical or a hypothesis. In this whole computation, there is what's called a critical value matrix, basically saying if your statistic exceeds that critical value within the matrix, then you have a statistically significant finding. Oh, actually, there's one other slide I wanted to show. So here's an example. I'm just going to leave it here instead of fight presenter view again. So first example is I want to look at a police department. So we saw in the descriptive statistics that each police department, Anchorage, St. Louis, and Kansas City, had mean scores, mean officer counts, but there was certainly variability that occurred across the years for each of those agencies. So I want to pose a question. Say, have we seen a significant change in the number of officers, not offices, officers, over the last 5 years? So in other words, has the St. Louis Police Department, as my example, has that department seen a significant change in personnel over the last 5 years, whether it's more personnel or less? My hypothesis is that there has been a change in personnel, but I'm not making any assumption about the direction. So a second ago when I said there's a matrix about critical values, if you exceed that value, you know you have a statistically significant finding. I skipped over the slide, but for this example, that critical value is 9.4. So let me go Anchorage. So in SQL, you can actually compute this formula, which is pretty cool. I mean, for me, I'm used to doing statistics in stata and SPSS. I had colleagues do it in R, like actual stats software programs. So the fact that you can do this in SQL to me is like, oh, that's amazing. Because my office isn't going to buy stata and SPSS. They're good with SQL. So big thing that we do in our data set, we have the observed values. What we need to do is compute the expected values. So in this example, in my hypothesis, I'm analyzing whether or not we see a change in personnel over 5 years. The null hypothesis, if we were to assume that there hasn't been a change in personnel, is that there would be equivalent staffing numbers across these 5 years. That's what we would expect to see. Uniform staffing across the years. So that's what this is. We get that expected value. We take the sum of the officer totals for those years divided by the number of years we're looking at. That will get us our uniform officer count. Within my output, I'm going to show you what the year's data are. But the syntax is actually quite simple. Once you get that expected value across those 5 years, again, all you have to do is minus that from the observed, square it, sum all that up, and then divide by the expected, of course. So this is the formula. Take your observed values, minus it by that expected, square that, divide it by expected, sum all that up. Here's what you get. All right, so I did Anchorage. So in Anchorage, 2019, they had 427 officers, then 425, 413, 400. Under the null hypothesis of uniformity, we would expect each year to be 414, 415 officers. So if you notice, the chi-square statistic at the bottom there is 1.3, which is lower than that critical value threshold. So the conclusion then is, yes, Anchorage Police Department has experienced changes in personnel numbers over the last 5 years, but statistically speaking, it's insignificant changes. Don't tell APD that. They will tell you that 6 officers is dramatically significant. But statistically speaking, it's really just not a big change. It's normal variability that you would see. St. Louis, totally different. In 2019, St. Louis had 1,201 officers. 2023, they had 926. You can already see in the observed values that we see year-to-year decreases. But again, the question is that decrease due to random chance, or could there be some empirical reality driving that change? And if you're going to answer that question, you need to see if you have a significant. And if you look at the bottom there, a chi-square statistic of 68, oh yeah. St. Louis Police Department has certainly experienced a significant drop in personnel over the last 5 years. Are they listening? I'm just kidding. All right. And then Kansas City. Kansas City is a little bit different. Certainly had significant changes in officer counts over the last 5 years. What? The conclusion here is they had a big drop in officers from 1 year to the next, and then it's starting to stabilize a little bit over the last couple of years. Notice, though, 3 agencies we looked at performing one statistical test using SQL, 3 different conclusions. So we can really have a solid understanding of what's going on with a particular agency simply by performing a descriptive statistics in SQL and hypothesis testing. Question?
Would you be able to automatically compute the critical value in SQL? That way you have a Boolean at the end that just compares your chi-square statistic to the critical value and says yes or no? Or...
Great question. The question was, can you compute this critical value matrix in SQL? Please don't even try. This matrix was created once upon a time ago. It's been debated across 1,000 different disciplines of what this matrix should look like. What I would suggest, if you want to use critical values and just pull that in instead of hard coding, create a table, call it the chi-square critical value matrix.
Specify your alpha and specify your freedom variables.
Yep. Yeah. So you would variabilize, like you said, the alpha value, your degrees of freedom, and then the actual critical value. Yep. All right. For the sake of time, I'm going to skip the 2-way chi-square because it really is effectively the same way that we compute the 1-way. I'm going to skip to a t-test. This was very fun to do in SQL. I mean that genuinely. Because honestly, I didn't think I could do this in SQL because SQL is not a stats software program. It's a data management program. So putting it simply, for those who don't know, a t-statistic compares the means across samples. So in this case, if I want to compare the mean officer counts for Anchorage Police Department to those of St. Louis to see if they're different from each other, a t-statistic is great to do that. Let's say for the DBAs in the audience, you have multiple servers and you're analyzing performance across the servers. T-statistic is great. You want to pick your counters, batch or latch numbers, latch weights from one server, compare that to latch weights of another server, see if you have a significant difference. Great statistic for that. Without going too much into the formula, here's what's going on. The top part here in both of these, you're comparing the mean scores across your samples. So you're comparing typicality. The bottom part is you're saying, okay, we've calculated the difference in means across these samples, but we need to put that in the context of the variability that exists within each sample and the size of the sample itself. So here you were comparing the officer counts per agency, given the variability of officer counts per year, and the fact that we're comparing 62 years worth of data. That's basically what that formula is doing. Oh, I have a visual to show you. So the one on the right, null hypothesis here, which is they're the same. The officer counts across the years are the same for the 2 agencies, would be the equivalent if you were to take those distributions, highlighted in pink here, and basically just overlap them. If they're overlapped, they're basically the same. If they're not, now you start talking about them being different. That would be this. So for this example, here's a scenario I want to look at. Do the police departments with the same coverage responsibilities have equal staffing? So St. Louis City is about 300,000 people. Anchorage, Alaska, also about 300,000 people. So in terms of population coverage, it's the same. Geographically, could not be more different. By the way, St. Louis City is like a neighborhood where I'm from. St. Louis City, I looked it up the other day, 60 square miles. Anchorage, 1,700 square miles. So it takes 90 minutes to get from the southernmost point to the northern. Yeah, geographically quite different. Coverage, well, about the same. So there's the question. Are similarly situated police agencies, do they have similar officer counts? You would expect them to. If you have to cover the same population size, you'd expect the officer counts to be the same. Also, I'll spare you the dramatic effect. They're totally different. This is going to be very involved for the script. So I do a lot of variabilizing to make it easy to handle within there because I just hate hard coding things and I hate writing things with multiple times. The dry principle. Question?
Session recording. Yes. And then second question, very interested, especially the dynamics of the
I can share my script. I don't have a GitHub, but I have my email on here. And so I'm more than happy to send the database itself, the data set, the scripts. I can send you everything. You just email me. Yeah. Okay. So first things first is we need to start computing the means and standard deviations and variances per agency. The top one here, I'm doing St. Louis. I get a count of the sample. I get a mean score across the years. I get standard deviation and variance. Again, what's the difference between variance and standard deviation? You need the variance for this statistic. That's the thing you just need to know. I do the same computation for Anchorage. Grab a number of years, the average officer count, standard deviation, and variance. And then in my final script here, I cross-join those two CTEs so that I can get all the output of both of those CTEs. And then I start doing the computation. I do the difference in mean scores across the agencies. I'm dividing that by the variability that exists within each agency, contextualized by the sample size of those agencies. And then I have a final script, final select statement here to actually produce me my statistic. So, and here's what it comes to. My t-statistic score was 10, with critical value was like 2. So, oh yeah, St. Louis and Anchorage have totally different staffing levels, which you can see in the breakdown here. So St. Louis has like 3 times the number of officers as Anchorage does. So the last slide here in conclusion that I want to say, and I know we're kind of rushing at the end here, is, again, I want to circle back to the whole point of analysis, whether you're analyzing a database system as a software application or substantive empirical realities like medicine, healthcare, pharmaceuticals, criminal justice in our world. That is in constant feedback in terms of the data production. There's a whole series of methodological techniques that you could use and approaches to take to sample that data, query it, clean it, and then start analyzing, not to get averages, but to get typicality. And then if you're going to put this into a larger model and put a lot of really cool visualizations into it, you definitely would want to perform some hypothesis testing. That will help you figure out what your model should look like and how complex and how big, how small when you suck it up into the Power BI. So thank you. Come on up. Yeah, thank you. This is awesome.
I got questions.
Yeah.
Yeah, I don't have much prepared, but my name's Doug. I'm with CGI. We've got some fellow CGI people here in the meeting as well. So definitely appreciate Murali and Julie and all of you for joining. Love having you all here. If you have any questions about CGI or what we do or anything like that, please feel free to reach out and talk to any of us. We're all really awesome people, or at least we like to think so. So yeah, thanks again.
Yeah, I'm going to say, and again, so my email's at the bottom there, and if anybody wants data, the scripts that I wrote and presented, just shoot me an email. More than happy to give it to you. Unfortunately not. Maybe in year 4 of being in technology, I'll get a GitHub. I'm only in year 3. Yeah.
Talk about putting these into stored procedures that you can specify table name, the column name you want to compare, or any parameterized get your email.
Yeah.
That way it's more usable.
Yeah, absolutely. For variabilizing and building stored procedures or functions to do some of the computation would certainly be a way to go. For purposes of the presentation, I kept it pretty hard-coded and pretty simple, because then if I added a layer of building the stored procedure, it would have just made it a little bit more difficult. But in our office, one of the things that we analyze is our Azure storage, and we created a function to do a linear regression that we put in all of our graphs so that all of our clients can have an actual predictive measure of where their storage is going. But yeah, for that, creating a function was the way to go. Yeah, and we just swap in client and a time span in that function. Yeah. Any other questions?